Hello students, welcome to Salsa classes. This is Dr. Sarkar over here and we were discussing protection of alcohols and deprotection of alcohols. So out here the strategy that we are going to discuss on is using ester protective groups for alcohols in which we propose that esters can be easily prepared by reacting an alcohol with an acid chloride. That is, we can synthesize a ROCOR prime. And how this can be synthesized? By reacting a ROH with R prime COCl, that is the acid chloride, using catalytic amount of a base to take up the HCl that will be released as the byproduct. And for the deprotection, we can simply think of, that is, for the deprotection to the alcohol, we can simply think of the use of basic hydrolysis of a ester. Okay. Now the commonly used ester groups include the acetate, that is COCH3, or can be abbreviated as AC. We may also use benzoate, which is COPH, or we call this as BZ. One may also employ or use pivaloate, which is basically COBU, that is the tertiary butyl group, or also abbreviated as PV. And these will be used for esterification of what? Used for esterification of primary alcohols mainly. And this can be also done in presence of secondary or tertiary alcohols. So if you have a molecule in which we have the tertiary alcohol and a primary alcohol, one may use these reagents to selectively esterify the primary alcohol, but nothing will happen to the tertiary alcohol. So to demonstrate this particular theory, we will be using this example in which we have again isopropanol, and we are treating this with a acid chloride plus the base for which we have given the reasons before. So this is add acyl protecting group, which will lead to the formation of this molecule, okay, wherein if R is CH3, then we will abbreviate this as or represent this as OAC, If the R is pH, then our molecule becomes or has the structure as follows. If it is p-valate, that is your R is a tertiary butyl group, then obviously our ester, will be having this type of a representation. Now, if we were to deesterify and regenerate, that is deprotect the ester and regenerate the alcohol, then one may think of using a base in presence of a alcohol, that is to say NH3 in presence of methyl alcohol, and that will lead to the cleavage of protecting group by base, and that will remove the ester protecting group as discussed above. Let us take an example. Now herein we have a cyclic ester, also known sometime as lactone. This is our cyclic ester. Okay. Now if this is treated with HCl, acid catalyzed opening of the lactone will take place as shown over here. So basically oxygen is getting protonated. That means this oxygen gets protonated, which will then be attacked by a chloride molecule. Cleavage will take place of the cyclic lactone, and the following molecule will be generated. Now within the reaction conditions used, decarboxylation will take place because this is a beta keto acid. So decarboxylation will take place and we will be able to generate this unusual molecule. Okay, so this is the molecule that will be generated. Now we have already discussed how carbonyl groups such as aldehydes and ketones can be protected using acetols or ketols. So here we are going to protect an alcohol using the same strategy. So we are considering out here acetal protective groups for alcohol. This is our topic. So out here we need to say that acetals will be produced on reaction of a carbonyl group with a diol. An acetal can serve as a protective group for either the functional groups, that is for an alcohol, or for the aldehyde or ketone. And the deprotection, as we have shown before, can be done by using acid in presence of water. Now out here, both the 1,2-diols and 1,3-diols can be used. 1,3-diols and 1,2 and 1,3-diols can be protected by the reaction of acetone and acid. Out here, obviously, it is the tosic acid. All right. And this will result in the formation of a cyclic acetal. So suppose we have this type of a 1,2-diol and we use the acetone in presence of the tosic acid. So out here, protection will lead to the formation of this type of a 1,3 derivatized dioxazolone, and which can be subsequently deprotonated using acidified water, okay, via hydrolysis, acid hydrolysis. Thank you for listening. Keep visiting Sarasa classes for further strategies of protecting functional groups in this lecture series. Thanks for listening and have a great day.